Imagine you're driving a car. When you press the accelerator, your speed increases. Press it harder and you go even faster. This seems so obvious that most people never question it. But what if you kept accelerating forever? Could you eventually reach the speed of light? And if you could, what would happen? According to modern physics, the universe has a built-in speed limit. Nothing with mass can reach the speed of light. And the reason why is one of the most fascinating discoveries in science. The speed of light is approximately 300 million meters per second. No matter where you are in the universe, every observer measures light traveling at exactly this speed. This idea became one of the foundations of Einstein's special relativity. At first, this seems impossible. Imagine you're on a train moving at 100 kilometers per hour. You throw a ball forward at 10 kilometers per hour. Someone standing outside the train would measure the ball moving at 110 kilometers per hour. The speeds simply add together. This works perfectly in everyday life, but light behaves differently. If a spaceship moves at 90% of the speed of light and turns on a flashlight, an outside observer still measures the light moving at the speed of light, not 190% of the speed of light, just the speed of light. The universe adjusts space and time themselves to make this possible, and this is where things become strange. As an object moves faster and faster, time begins to slow down relative to outside observers. This effect is called time dilation. The amount of time dilation is described by a quantity called the Lorentz factor. The equation is this: gamma equals 1 divided by the square root of 1 minus velocity squared divided by the speed of light squared. As velocity increases, the denominator becomes smaller, and as the denominator becomes smaller, gamma becomes larger. At low speeds, gamma is almost exactly 1, so relativistic effects are negligible. But near the speed of light, gamma increases dramatically. Let's look at an example. Suppose a spacecraft travels at 90% of the speed of light. The velocity divided by the speed of light is 0.9. Squaring this gives 0.81. 1 minus 0.81 equals 0.19. The square root of 0.19 is approximately 0.436. 1 divided by 0.436 gives approximately 2.29. This means time on the spacecraft runs about 2.29 times slower than for an outside observer. Now let's increase the speed. At 99% of the speed of light, gamma becomes approximately 7.09. At 99.9% of the speed of light, gamma becomes approximately 22.4. At 99.99% of the speed of light, gamma becomes approximately 70.7. Notice what is happening. Every small increase in speed requires a much larger increase in energy. As velocity approaches the speed of light, the required energy approaches infinity, and that is the key. To reach the speed of light, an object with mass would require an infinite amount of energy. Since infinite energy does not exist, the speed of light can never be reached. No matter how powerful your engine is, no matter how advanced your technology becomes, you can get closer and closer to the speed of light, but you can never actually arrive. This is why the speed of light is not just a fast speed, it is a fundamental limit built into the structure of space-time itself. And surprisingly, this limit may be one of the reasons our universe remains consistent. If information could travel faster than light, effects could occur before their causes. In some reference frames, messages could arrive before they were sent. The distinction between past and future would begin to break down. So the cosmic speed limit is not merely a restriction. It may be one of the rules that keeps causality intact and prevents the universe from becoming paradoxical. The next time you look at a beam of light, remember that it is traveling at the maximum speed allowed by reality itself, a speed so special that space contracts, time slows, and the laws of physics reshape themselves to ensure that nothing with mass can ever catch it.